these exercises are designed just to get you using the laws of logarithms. So that the target in question 1 here is to basically combine these log expressions into one single one. And the only rules that you can use are these rules written here in red. So what I'm going to do, I'll take a sort of obvious one. Question 1c, for example. So your target is to take a log expression, and at the end we should be able to work through this problem, going through various lines, and at the end we just want log something. That's our target, okay? We want to combine it into one single logarithm. Now, when you've got an expression like this one, you always start from the outside and work your way in. Now, what I mean by that is, if you have, we're going to combine two logs. If you've got something, I'll say, outside the logarithm. So, if I put brackets around that log 2, you can see I can say that 2 is outside the logarithm. So your first step is, anything that's outside that logarithm, you want to get it inside. Like that. Now, if I number the rows over at the side here, now remember that these rows or these laws, these laws, is it properly, boys? These laws can be worked in reverse as well. Which of those laws am I going to use to bring that 2 inside? First, second, or third? Third one, this one here. N log x, because what happens if you look at that row, the n basically comes inside and becomes a power. So my next line in this one will be log. Now these are all, if you don't see the base, what base are these numbers? Or these logarithms? 10, it's base 10. So that 2 comes inside and it becomes a power, like that. So now I've succeeded, and that's what I mean by bringing everything inside. Now once I've brought everything inside, which rule am I going to use to combine those 2 single logs into one log? First, second, or third? First one, because if it's a plus, you can bring these things together. Now, you can always write logs with brackets there. What you'll see in practice is that bracket's usually just missed out. So, if I do it without the bracket, I've got to multiply these 2 numbers now to bring them together. 2 squared is 4, and so the final answer is log 16. Now, you could actually check the answer. We haven't used calculators with logs yet, but as you know, you've actually got a log button in your calculator. That's that button there. So if I do log of 16, there's my answer. Now if I've got it right, if I then do 2 times log, where are you? 2 times log of 2, close brackets, and then plus, I actually haven't tried this previously. Let's just see if it does give us the same answer, or maybe I need to put an extra bracket in here somewhere. Let's have a look. Okay, now it doesn't work, which means that when I do this, then probably I've got to put a bracket around this one. So let's see, 2 log 2, close bracket, and then I'll close the bracket again. So it's that one multiplied by 2 plus. So this is actually, as well, if you do this type of thing, it's a good practice for using your logs in the calculator, even though the exercise doesn't ask you to do this.
Why is it times 4?
Have I made a mistake? 2 times, should be 4, should be log 16. Now I'm not getting the same answer there. Can anyone spot a mistake in the working?
Why is it times 4 though?
Oh, that's the mistake, isn't it? Let's go back. So, using the calculator, I couldn't spot the mistake there, but yes, here, for some reason I was timesing by 4. What should I be timesing by? So the answer is 12. Let's just confirm that. That's the answer. Now that's just a demonstration of sometimes, if you get the chance, That's a good example of checking your answer, right? The idea of, it's a bit like doing your investigation when you have to validate something. I'm checking the answers from different directions. Use my calculator, so obviously I had a mistake there, I couldn't see it. And then someone spotted it.
Can you do another exercise, maybe H?
Yeah, we'll try another one, right? We're going to do a few. Okay, so that was 1C. Now they've all got different factors to them. Before I do 1C, let's have a look, for example, at the one with the fraction in it. How are we gonna? Let's see how we handle the one with the fraction. It's a half log 4 minus log 2. So what I said to you is, what's your first task? What do you want to do first here to combine them? What one am I going to focus on? Which number? Anyone? Remember I said start from the outside and bring things in? Yeah, that's the focus. That's outside the logs. Sorry, it's in front of the logs. Let's get that inside. So using the third law of logarithms, it comes in and it becomes a power. Now at this stage, I'm thinking in my head, over here, well, fractional indices, what does that mean? Remember, lots of people think it means this. That's a load of nonsense. That's negative powers that make fractions. What does a power and a half mean?
Half of it. 2. So power 1 over half.
No.
It's negative 1.
What does a fractional power do? What's it about?
Oh, it's the root.
It's the roots, that's right. It's the square root. So 4 to the power half means the square root of 4, which is 2. Now, obviously, we don't normally write that 2 above there, but you can get things like cube roots. We've done all sorts of roots in the last few weeks. So that's basically what log to the base 4 at 4 to the power half means. And we're going to minus log 2 here. Now, what I can simply do at this stage, if I wanted, 4 to the power half is 2, as I've just shown you over there, minus log 2. So in fact, this simplifies right down. Log 2 minus log 2 should equal 0. Now, if we did something different here, what if we instead used the laws of logarithms? Well, if we join these together, we have to divide those numbers. Remember, a subtraction in logarithms is a division here. Now that gives us log 1. Now that doesn't look like it's the same as this answer over here. Right, so what's going on? Well, remember how you've been shown how you can do the values of logarithms. Remember the circular thinking. What is that, the value of that? Now remember this thinking here? What is it we're trying to demonstrate with that? What's the idea? What is it you should actually be thinking of in your head here? Did I teach you this circular method when it comes to logarithms? What am I saying there? No one?
No one.
No one can explain that. Remember, you just did an exercise on it, people. What is it? What's the thinking that goes on here?
0.
Ten to what power is going to give us the answer 1? 0. Okay, so the question mark is equal to 0 there. In other words, if you're using base 10, the log to base 10 of 1 is actually equal to 0, so that answer is correct. But all you're doing is, that's just an extra thing for you to think about, but all you're really doing here is you're just using the laws of logarithms. Now we had a request there for one to try.
Yeah, H.
Okay, let's try H then. So how would we handle H? Okay, it's got negative numbers in it. Minus log 2 minus log 3. We don't need to worry too much about that subtraction because we know that that can be changed into a division for two things that are subtracting. So I've got no worries about that. That's okay. Is this minus here that's a problem?
Yeah, the answer is different. It's not a fraction.
Right, now hang on. What we do here then is, let's change this into actually the number minus 1. And let's bring the number minus 1 inside. So it then becomes a power. 2 to the power minus 1 minus log 3. Now, this time, 2 to the power minus 1, well, that's just a half. That means 1 over 2 to the power 1 minus log 3. So now I've brought the minus inside. So if we keep going down here then, now we can concentrate on that minus. So I'm going to be using this rule here. I get log. Okay, so you're going to have to be using fractions here. A half divided by 3.
Yeah, but the answer is it's -6. It's negative log 6.
Now I've got log 1 over 6. Right, that's a half divided by 3, so just multiply the bottom numbers. Log 1 over 6. Now you say you check the answers. What's the answer at the back?
It says negative log 6 or negative log 1 over 6. Why can't it be that
Right, how in the answers then, how do they have minus log 6? Well, what I can actually do is I do the reverse of what I've done here. So I could actually say, well, that log to the 1 over 6 is actually log 6 to the power minus 1. And then do the reverse. Let's take it back outside now. And that's how you get the alternative version. Okay? It's just doing it in reverse. So you really need to just go through question 1 there and use your rules. So is there any other? Oh, now there was one that you have to watch out for as well. Problems where you just have a number in them. Not so obvious to do. So if I just show you L very quickly here. 1 plus log 2. Right, the trick to doing this, you need to have log if you're going to combine these things. So when you get to this question, the tactic is you've got to somehow change that into a log expression. And this is that's the hardest bit to do. So what you've actually got to do here is a bit of roundabout thinking. You're thinking log something gives you the number 1, and then I can replace that 1 with the log. Now what's important to realise is this is base 10. So 10 to the power 1 gives us what number?
10.
10. So what I can do is, using that circular thinking, 10 to the power 1 gives me, so 10 actually goes in the inside there. So I can replace the 1 in this problem with log 10 plus log 2. So once I actually do that, you can see it becomes pretty simple to get the final answer. We just multiply. Now that's what I mean about learning small tricks. It's not obvious, really, how to do that one. But once you've seen one example, you can just know that if you get any problem with the number, the trick is to take that number, and somehow turn it into the equivalent log expression for the number 1. Right, I want you to get started on that, and in a short while we'll then talk about how we can do question 3, which is slightly different. Question 3, and I think also question 4 as well. So we'll do a recording of that separately. So everyone just get started on question 1 just now, and you stop this one here.